those of you who are new today to this event, and welcome to the 6th Women in Software Engineering event of the series. Just a bit of a background to Women in Czech Republic. So we founded the initiative back in October 2019, and it's an employee-led effort aimed to encourage more women into tech and to create an industry that's totally diverse and inclusive, and also to develop and inspire the careers of female technologists, and to really kind of challenge the gender imbalance that exists in the industry today. And so for today, a 6th event of our software engineering series, I'd like to introduce and to pass over to Ebaa. Ebaa will be doing a live demo on the Finite-State machines, and we'll be covering everything you need to know around that. So I'll pass over to you, Ebaa.
Hello, and thank you for this opportunity. Thank you all for joining this event. We're gonna talk today about the finite-state machine. My name is Ebaa Bassoumi, and I would like to introduce myself first before going to the talk. So I am a full-stack software engineer working at Jimdo. Originally from Palestine, and I'm living now in Hamburg, Germany. I'm doing my master thesis in MBA in Big Data. I became a new mother for a lovely baby, and I love baking. I tried paragliding once, and it was, wow, amazing. I would like to try it more. My favorite programming language is Java. But today we will gonna code using JavaScript, and don't ask me why, because I don't know why. While I was preparing for this talk, I came across a term. It's a combinatorial explosion term. And I thought it was worth mentioning here that we as developers, we sometimes build a new feature. And once we want to test this feature, out of nowhere, other features are not working anymore. And this is because we are reaching this point where when the problem is increasing, the problem size is increasing, the ways of interacting with the app is increasing. It increases the number of combinations and computations that the user can interact with our app. This leads to this point, which we don't actually prefer to reach. Using the finite-state machine computational model will help us to avoid this case. So just keep this in mind, because we're gonna talk about this later, okay? We're gonna talk today about two fundamental computer science concepts. We're gonna talk about the finite-state machines. We're gonna talk about the actor model, and we will have a live demo how to implement those in the code. So what is the finite-state machine? Before going into the theoretical definition of the finite-state machine, let's have an example. So we have a car. You want to drive the car. You know, what do you know about the car? You know the gear shift, you know the pedals, you know the wheels. So you know that you drive, it works, everything is cool. But you don't actually know how the car is implemented inside, and you don't really care. What if you want to operate this car in a very limit of its capabilities? In this case, you wanna read more about how automobiles working. The same goes for programming. So if you are just building a contact form, I don't see that you really need to know computational models to implement this form. But if you are dealing with a code that requires more serious computations, you actually need to understand what computational models you may use. One of those computational abstraction methods that you can use is the finite-state machine. So as mentioned, it's a mathematical abstraction method or model you can use to actually visualize your code in a sequential logic. So in other words, you can present your code and your app, and you can have control execution over the flow of the app. What is the basic building of state machine? So the basic building blocks of state machines are three basic building blocks. We have the state, we have the input event, and we have the transitions. You can here see the state as our as the mode or status of the app. So you can ask yourself, what is the state of my app at this given point of time? And you should always remember that at any given point of time, you can only be in a one single state. So let's see, you're asleep now. You cannot be asleep and awake in the same time, okay, right? So you're asleep and your alarm is on, the sun is out, there is construction outside the building, and it's Monday and you need to work. All of those triggers you to make a transition from your state asleep to be awake. And I hope this transition is not bad for you. So this is just a simple example of states in our daily life. If we want to talk about real world example, I chose to talk about the traffic light system because we are all familiar with. So in traffic light, we have the green. As you may know, we have the yellow and we have the red. In order to change from green to yellow or from yellow to red, we need to trigger something here. And if we put ourselves in the shoes of people who actually designed this system, we can say that they used this state concept. So we have 3 states here, as I mentioned. In order to go from green to yellow, let's have a timer. And this timer, when it's expired, the states is changed and there is a transition on our states from green to yellow. The same happens from yellow to red, and the same thing for red to green. And that's going on. So this is a real world example. Let's see how can we implement this in our code. Suppose that you need to fetch data from an API. What you need to do here? First of all, you don't need to do anything because you didn't request the data. And whenever you see this here, this tiny thing here, I meant by this is that I am in the initial state. And initial state is very important to be defined because in every machine, we should know what is the initial state of my app or what is the initial state of my machine when I don't do anything actually. So here we are in the idle state. Now we want to request the data. So we trigger an event, which is fetch here. This fetch will make a transition from the idle state to the binding state. The binding or loading the data. We are here loading data from the external API, from backend server. Once we have a response, we may have 2 results. We may have an error or we may have the data that we asked for, which is resolved. So we can suppose that we have 2 events here, resolved and rejected. Resolved will trigger my state to transit to receive data or resolved state. The rejected will trigger me to go to the error state. And if you look deeply to this graph, it's actually the promise, which I may assume that most of you are already familiar with the promise and how to implement it in the code. Now the question is, why to use the finite-state machine? As we have seen so far, defining finite-state machines was by the modeling of the logic before I actually implemented the code. So I have a visualized model and I have a precise diagram. So let's suppose that one of you as a project manager, and he asked me to build this feature. Before I actually start to implement this feature in my code, I could implement the logic in a finite-state machine model. And then I go to my project owner or project manager and I say, hello, this is the requirements you asked for. And this is the model, this is the sequential logic that I will implement. Is this okay? Can I have the approval for it or not? And we can obviously see here the benefit of just making the model before writing the code. And actually, if we want to have a feedback from people who really don't need to have a background of a technical background, this is also a great benefit for them. One of other benefits of finite-state machine is that it's a very good comprehensive test coverage. So when we know the states, we know the transitions, we know the flow, how it is go. We can predict how the test cases should be implemented. Finally, if we have, there is almost no project that we start building it and there is no changing requirements during the coding. So whenever I have a model for my logic from the beginning, whenever there is some new changes or new requirements, I can know exactly this change, what will this change affect and how it will affect the behavior of the logic. And this will also this will help me to accommodate to this requirement fast and in the best way. Let's move to the actor model. The actor model, what is the actor? Everything can be the actor. Everything can send anything that can send message or receive message or actually do something with this message. We can call it an actor. So here I am an actor, I am sending a message. You are actors, you are receiving a message. My machine is an actor, it's processing some messages and so on. So we will use the finite state machine beside the actor model to implement a very basic code in a very simple way, and you will be happy with the result, I think. I hope so. State management library. So from now we're gonna have an example of a library that we used at Jimdo, and we really see its benefits for managing our state in the app. As some of you may know, in frontend, for example, we have Redux and Mobix and other tools to manage the data in the app. But what is really advantage in this library we're gonna talk about, which is Xstate, is that it's not only managing the data, it's managing the state of the app as well. I have some screenshots here from the official documentation of Xstate, which I really recommend, because it's really clear, so you can have a deep idea about how to implement the Xstate. Here, we need all you need to do is just to implement it, to import the library of Xstate. From the library, you can call the machine function. In the machine, you can create the object or which is actual your machine. This object should contain the ID, which is the ID of your machine, which should be unique. The initial state, as mentioned before, every state machine should have an initial state to start from. And a context. So this is interesting here. Whenever I have a quantitative data, I would like to save it somewhere. And this context is the ideal place to save the quantitative data for my machine. You can see it as an extended state. And lastly, we have the state definitions. So if you see here, we have the green, yellow, and red, which you may remember now that we talked about the traffic light system. Events, we talked about events. It's the thing that trigger the transition for the state. For example, we have here three states, 1, 2, and 3. I am in the 1 because 1 is the initial state. Then I receive an event. The event is a click. Whenever a user sends this event, a click, I am triggered to make a transition to 2. However, what about if the user sent stop or send hi? Should I make any transition? No, because I only respond if the event is a click. Now I move to the state 2. Oh, this is good. So this is known as a null event. What is null event? Null event means that I don't care what the event I receive. Whatever I receive, I will make the transition. So here I move to 2, but I have null event, which makes me the target 3, which tell me that I should go to 3. I am going to 3. The 3 here is final. Okay, final means that I am done with my machine. That's it. Actions is also a very interesting concept in Xstate machine. You will gonna use it a lot if you use this library, because actions is this kind of functions we fire and forget. Whenever you want to fire some function and you want just to fire and forget it, like assign something, log something, action is the ideal place to do it. After we define the machine, we have this action part here, where we can do our side effects, our desired side effects. We have 3 types of actions. We have entry actions, which actually the actions that you want to fire once you enter this state, and you can see the syntax here. We have an exit actions, which are the actions that you want to fire once you are leaving this state. And you have the transition actions. What is the transition actions? Is that this action is only related or connected with this event. So whenever I receive this event and I do this transition, I do this action. And final states, we talked about this before. So it is actually the state that defines that I am the final node and the machine is done. Not every state machine should have a final state. It depends on your logic and whether you need really to stop the machine or you need to keep it working. So this is not mandatory. Invoke services. I call this part actually the magic of the machine. So inside the machine, you can invoke services, which we call before actors. You can invoke promises, you can invoke other machines, you can invoke observables, you can invoke callbacks, whatever you want to invoke inside your state. The syntax for invoking a service is using this magic word here, invoke. You specify the ID of your service, you specify the source of the service, and what is interesting in here is those two events, on done and on error. So what does it mean? Whenever my service here, fetch user, is done and I receive, suppose this fetch user is a promise and the promise was resolved, so I am done. So this event will be triggered, I will go to success. Whenever I have an error and the promise was rejected, I go to this event here, which make me transit to failure. You will use this a lot in the state machine. Invoking other machines. So as we mentioned, you can also connect machines together. So you can have a parent machine, you can have a child machine, and they can communicate with each other. So the parent to child, it can send with event and the payload that I want to send to the child. The same way from child to parent, I can send data or event to the parent, send parent, using this send parent. I hope everything now is clear, because we're gonna implement what was presented now in a live demo. I prepared just a draft demo for this talk. It's very yes, it's a simple app. What we want to do actually is we're gonna implement this. We're gonna implement this app here. We want to implement a corona system to check if I am allowed to travel to this country or not. And we do this by choosing a country here, and depending on the selected country, we see the data here. So what is done now is just a dummy data ABC. This should be changed using our state machine. So I will ask you now, according to what has mentioned so far, how could this be implemented? What can you imagine which states do we need? Because one important thing when you are implementing a finite state machine is that before writing any line of code, you should always ask yourself, what is the behavior of my application? What are the different states? What should trigger my states to change? So depending on this here in this draft app here, I can say that the first state is the idle. So I am not choosing any country actually. If I choose a country, then I should move. I should select, depending on my selected country, I should make a transition to loading the data for this country. Whether I receive whether my response was received and there was no error, I am going to the done state. If I receive an error, I will go to the error state. Here I choose not, if I want to done state, I choose not to close my machine. In fact, I want the user to be able to select another country. So whenever I am in done, I would like also to be available to send the event select again to the loading, and then the loop will start again. Now I am here in this selection. I want to load the countries before actually selecting a country. So whenever I am starting my machine, I also want to invoke a service that gets the country list for me. Whenever I am in the loading, I want to take this country, the country that the user has selected, and then get the country data. I hope this is clear, because we're gonna implement exactly this graph in our app. So here is the code, and what I did so far is that I imported the libraries for Xstate. So what you will need is Xstate, and this is a React app. So I need also this library here, Xstate React. This Xstate inspect is actually interesting library, because it doesn't affect the code, but when you use it, you can see how the flow visualized, and we will see how this is working now. What I have here is two services. The first service is getting as mentioned here, getting the country list. So this is a URL for getting a country list, open URL. And this is a URL for getting the the data depending on the selected country. What I want to now use is I want to create my my machine. What we do is that export the constant, and we can choose whatever name we would like to. Corona machine equal. What we said is that we can use this already defined function in Xstate machine, and we can create the object. What object should have is the ID. I would give it the same name as Corona machine. It should also have the initial state, which is idle in this case. What else? Yeah, the context. I need the context because I need to save the data, because we have already a quantitative data in mind. List countries, yeah, which is an empty array at the beginning. The country that the user has selected, and cases. We may have what else we. I have the API here called. So if I want to call to fire this API for Germany, I can see that I can get those data. So what I'm interested in, the cases, the deaths, the recovered. Okay, perfect. I have the all data I need. Recovered per million, active per million. Okay, perfect. So let's have just some of those data, like deaths, recovered, what else I may need? Okay, this active, let's say, and active per 1 million. What is this? Yeah, active and active 1 million. Okay, now we should define the states. So states is the first state we say is the idle. Let's keep it empty now. Loading, done, and error. And what we said about the error, it is our final state. So let's type final. Idle. What we said that we want to do in the idle, we want to fire this event. Okay, this service. So we use this magic word as we mentioned, invoke. The ID is get list of countries. The source is the source actually is this the service itself, and we need actions here. Yes. yes, we need actions here. And one of interesting actions that you may use a lot is the assign, where you assign data. So assign here, I want to assign those data. Yes, this is list country. So I want to assign the country actually to from the object, from the response. So I receive the event. I receive the event and event.data.countries. Perfect. Okay, now we can use the on done and on error. Well, yeah, okay, sorry, I forget here that this should be done on done, the action. And yes, perfect. And here on error, if I receive an error, where I should go to the target. I should close my machine and go to the error state. The same thing will be done in loading, so I will not write it again. I will just copy it from somewhere. Yes, I will use it. It's the same thing actually. We use different service here for fetching the data. Perfect. On done. Okay. Now we should make the idle accept the select event, which is like here. We define that we only will accept the select event. What will happen when we receive the select event is that we will go to the loading state and we will assign the selected country that the user has select to our context. Okay, so event.country. Perfect. What else? Oh yeah, we mentioned that we want the done to do the same as the idle whenever we select a country. So we just do the same as here. Whenever we select a country, we assign this country and we go to the loading state. Perfect. So we are done now with the machine. Simple. Okay, we want just to show this data that we requested. So here, what we see here is just labels, empty labels. We want to put the data actually. So there is something in Xstate, a hook for using the machine here. So we can just use machine, and we can write the name of the machine, which is Corona machine, and I will write just this little parameter here, DevTools true, which will enable me to use the inspect that I mentioned before. This is not imported. Perfect. I don't need this dummy list of countries because now I have my real list of countries, which is I could get it from here. Current state dot context dot list of countries. Okay, perfect. What else should I do? Yes, whenever I receive whenever the user select a country, I should send a select event, and I should send the data as well. So country, it is from the selected options. Yes, I hope we did it right now. So let's test it. Yes, let's just fill those data with my real data. So context dot cases here. Here I need context dot active, context dot this, context dot recovered. Okay, so depths here, active, recovered. Okay, and I want to make sure that whenever there is an active cases, there are active cases more than active cases, active per 1 million. Okay, whenever there is an active cases less than 500, let's say, I could go to there is no travel restrictions. But if there is more, I should go. I should have a negative PCR. Perfect. Yes, let's run the app. Oh, what am I missing here? Okay, let's run the app. So this is, I just did this before the talk, so this is what the expected result. Yeah, this is deployed on my GitHub account. So thank you all, and just let me know if you have any question.
Thank you, Ebaa. That was really, really interesting. I mean, we did actually have a question as you was going through the demo, which was around the context, and Mage asked if the context working, or is the context working as a global state?
Yes. So and let's have an example as Redux. Redux have this idea that we have this global state over the app, and this whenever we have an update, we go to update this global state. But in Xstate, actually, we don't need always to be updated whenever there is a change. In Xstate, we are not updated unless this machine is sending an update to us. So this is a great benefit for us. So yes, it's acting like a global state, but it's not. We are not getting updated whenever there is a change. Actually, yeah.
We just had a question come through around Xstate. So in Xstate, could we set conditions to decide the initial state based on the page user opens, or is it always set the first state as initial defined?
Yes, this is a good question, Regan. Thank you. Yes, we have guarded transitions. So we have some Xstate has this extension to use guards. So you can set some guards as conditions, and whenever this guard is true, you go you do this transition.
I have another question. You have called the use machine in your draft page. What if I need to use it in another place? Should I call use machine again? And yeah, if I called it again, then I'll be in the loading state again and fire another request, or what?
Yes, you should remember that this use machine is a hook, so you should also always use it in the high level. And yes, whenever you call this machine, you are going requesting the machine that is currently on. So you go to the current running machine.
Thank you very much, Ebaa, for your time, for the demo, and for the presentation. I mean, I'm sure everyone can agree it was really insightful and it was really interesting to learn more around. So thank you for your time this evening, and thank you to everyone who came along as well.